So, this happened.
Hey, what's going on, guys? So, not really sure why you keep showing up, but as long as you're here, let's talk about some injection mold machine stuff, shall we? This is the APSX-PIM, or PIM, I'm not really sure. But it's probably the most affordable of the desktop sort of sized injection mold machines. To be honest, there really aren't that many in this market. This one costs about $12,000. And yes, that is a lot of money. It's a lot of money for us, for sure. But when you look at the sort of value proposition for an injection mold machine, if you're planning on making something in an injection mold machine, you're looking at 10 grand no matter what. That's what it'll cost you in America or probably even in China for one mold. So you've got a design for a part, that's all you get. You can have 10,000 of those parts, but if you want to make any design changes, you're pretty much screwed. So for us, it made sense to get this. We've got the CNC machine behind me that we can make any mold we want. And it's something, honestly, we've wanted to get into for a little while. So before we get into the details, here's a really quick overview of what injection molding is. And quick note, if you have anything made of plastic sitting around you, almost certainly it was injection molded. Industry uses them for just about everything these days. But the very basics are simple. You take hot plastic and you force it into a mold. That mold cools the plastic and you get a finished part. The details, though, get pretty complicated. You need a fair amount of sensors to know what's going on in the process. The pressures are pretty high, the temperatures are pretty high, and you need a pretty repeatable mechanical solution. So if you're looking at this and wondering, is this physics anonymous? Why didn't you guys build one? Well, to be honest, we thought about it. But we also probably thought you wanted your knives, I don't know, sometime in the next 3 or 4 years. So with our reputation on building machines and finishing them, we thought maybe it would be better just to buy one. So let's get the stats out of the way. This machine has an injection volume of 30 cubic centimeters, a max temperature of 315 degrees C or about 600 F, a max injection pressure of 345 bar, and 5 tons of clamping force. So what does all that mean? Honestly, I have no idea. But from what I can tell, it means you can make pretty strong parts out of just about any thermoform plastic. And you can make those parts in about 2 minutes apart, which is pretty awesome. But how does it work? The first thing that happens is the plastic is brought up to temperature in the barrel. In our case, we're using glass fiber reinforced nylon. So the temperatures are maybe 270, 275 degrees Celsius. Once the plastic is up to temperature, you want to build pressure in that cylinder. This is done by a stepper motor compressing this large spring and forcing a piston into that cylinder. Once the pressure is built, you clamp together your mold, which is generally 2 pieces, but not always. And then a valve is released, releasing all of that pressure of the plastic straight into the mold. It's important that this happens pretty quickly because the plastic solidifies fairly quickly. And if it doesn't all get into the nooks and crannies in time, you end up with a partial piece. We've got a lot of those sitting around. So you can see the temperature of the mold, the temperature of the plastic, how much pressure the plastic is under, how much clamping force you're using on the mold. All of these factors have to work together. Otherwise, you end up with leaks or unfilled molds, or all kinds of things can go wrong. There's also a lot of things that have to be really consistent, because as soon as that mold is done, the part separates. If you've set up your injector pins properly, the piece gets ejected out of one side of the mold and falls into a bucket. We haven't quite got that far, but we'll get into that later. In any case, once that happens, it has to do it again and again and again. Generally, injection mold machines run all day, every day, pumping out parts. And as soon as the machine gets hung up on one of these things, if it can't maintain temperature or you lose pressure, the machine stops. You have to have somebody come over and unclog it, and it kind of defeats the purpose of doing high production stuff. Now, admittedly, this machine is not meant to pump out 10,000, 100,000 units a day. We're looking at probably putting out, 200 pieces a day. We'll see how it goes, but I think that machine is perfectly capable of that. We do intend on babysitting the machine a little bit, because, well, we're new at it and we don't want to set anything on fire. And to be honest, it's pretty cool to watch. Well, enough about the machine. Why did we buy one in the first place? The short answer is Project Alpha. It's the knife we've been building for the past few months, and if you're not familiar with the project, maybe go check out one of our older videos. I don't want to sound like I'm bragging, but it's pretty awesome. All right, just to make it super clear on the part I'm talking about, let's open one of the old prototypes of the knife and take a look. All right, here's the original prototype. Now this interior piece we call the carriage is machined out of a single piece of nylon, and for the prototype this worked well, but machine times were kind of obnoxious, and it also required 4 or 5 different setups to get all the features we needed, and so it was just too time consuming for the amount of pieces we need to make. The other problem is it's extra components that we don't need. Not only do you have this nylon piece, but you've got another nylon piece here that has to be machined as the button. This particular one is 3D printed. You also have this leaf spring that requires it to be bent in a very specific shape and length, and 2 extra screws to hold the thing on. That's why we changed it out for this single piece design. This is also nylon, but it's fiber reinforced. This was pure nylon. The fiber does a few things for us. It makes the whole thing a little stiffer, which allows us to build the spring right into the model. It also makes the cycle life on the nylon much higher, so you're never going to wear this part out. You can see it doesn't have to flex much to be the button as well. And it reduces parts. It's all one piece, no more screws, no more spring. The only difficult part is getting this thing injection molded. You see, this particular one is missing a few features. It doesn't have the slot yet for the blade. That's something we're going to have to machine in later. This hole also we drilled with the CNC, but we've got some good fixtures for that. We're going to show you that in a later video. And those features could be built into the mold, but because technically they're undercuts, you'd have to have some moving parts. And to be honest, we're just not quite there yet with our molds. But you can see this works just the same as the other one. If I put it in this carriage, you can see that it clicks into place, both sides. It locks the way it's supposed to on this side. Press the button, and it unlocks. All right, to be honest, to get to this point in the injection molding process took a few tries. And I want to run you through kind of our trials and tribulations on what went well and frankly what didn't go well. So let's get into it. Oh, and if you're curious about this electric screwdriver, there's a link in the description. All right, here's our very first mold. Now we decided to split up into 2 pieces because, well, we knew we were going to be making a lot of mistakes along the way. We didn't want to waste all the extra work in putting all these extra features and pins in the main mold when the mistakes we were going to be making were going to be happening really only in the center piece. So we decided to make this into an insert. So this fits in really nice and snug into this piece like that with very little clearance so that it kind of always locks into the same piece. And I'm really happy we did that because we went through a few iterations of this design, both because we were learning a lot about injection molding and we were learning a fair bit about the material properties of the nylon. For example, in this first piece, I thought this may be springy enough, but it is very stiff, and under full load on that spring, it's actually moving past its plasticity and permanently deforming, even if it's just a tiny bit. This design was out. We move on to version number 2. All right, so this is version number 2. Looks a lot like the first version, except you notice we're doing 2 pieces at once. You'll also notice there are a few extra features in this. There's some extra holes that weren't there before. Those are actually for ejector pins. So one of the critical parts about the mold is that once it's done injecting, this whole piece gets pushed back into a plunger on this side that forces those ejector pins to push through the machine and press out your piece, which means ideally, once the machine is done, your piece falls to a little bucket below the machine and it's ready to go for the next one. If you don't have those ejector pins, pulling something out of these molds is a pain in the butt. You really have to take the mold apart and you have to pry, and you're almost certainly going to deform your part when you do it. So although injector pins seem like a nice feature to have, in this particular case, I think they're really necessary. So that was the purpose of this particular mold, is really to understand ejector pins, how they work, what kind of tolerances you need. We're using 1/8" ejector pins. In fact, let me show you one of these to show you what it looks like. All right, here's what a standard ejector pin looks like. They're made of hardened steel and they're precision ground. They've got a little head on the end. So that actually fits inside the mold like this. This particular one is the wrong size. It's a smaller ejector pin. But you can see what happens is this all gets mounted into a spring-loaded piece in the back. And as the piece comes back and hits that plunger, those ejector pins push out and push your piece out of the mold. And we learned a ton with this particular one. We have to drill and ream these holes. We figured that out because that has to be such a tight fit that plastic doesn't seep between the ejector pin and the mold. So you're talking probably half a thou of clearance in that hole to make sure that doesn't happen. They also have to be ground very flat, otherwise you end up seeing them in the part, which you don't really want. You're always going to see a little bit of that. In fact, if you pick up about any piece of plastic that you own that has been injection molded, chances are you can see the impression of those ejector pins somewhere on that part. So not uncommon, but you want it sort of as flat as possible. We moved on from this design to this one. So you can see that we actually took a few steps back on this. There's no ejector pins, there's only one mold on this side, there isn't anything on that side. And that's because in this case we were really trying to test the dimensions and the design of the carriage itself. And so I didn't want to repeat a bunch of work, so I only did one side. We also changed the way that these two pieces work. In this previous one, you can see this piece right here we call the island is a separate piece and it bolts on from the back. This didn't work well for a number of reasons. It was too easy for plastic to get underneath it and in that little separation on the side. And also trying to align this thing as you screw it down was almost impossible. So in this design, we split it in a different place. You can see we've got two separate pieces there. This being pretty easy to machine. You can see almost all of this was done with a 1/4 inch or an 1/8 inch end mill. The other nice thing about this mold is we sort of have a labyrinth seal around where plastic can get. So you can get a little plastic seepage right in that little corner and right in that little corner, but we found we could machine tight enough tolerances to where that didn't happen. Which brings me to version number 3. Or is it 4? I've lost track. All right, this is our latest version of the mold as of the making of this video. And you can tell it has most of the features that we need. We're making 2 parts at one time. We also have these tiny little pins in here. Those correspond to the holes in the carriage. This one's pretty simple. It's a straight through hole. These are a bit more complicated because they have 3 features built into them. There's the boss for the head of the bolt. There's clearance for the threads on one side. And the very bottom is where the threads engage the plastic. So pretty complicated, but once the mold is done, you only have to do it once, which is the nice part, and then you end up with a bunch of these. The other feature that this mold has is full ejector pins. You see if I push the whole thing down, the pins stay in place and everything else moves down. This ejects the plastic out of the mold when it's fully cooled. And you can see a little bit about how this works. It's all spring-loaded. In fact, let me pull this whole thing out of the mold so you can see it. All right, so here's our basic mold insert. You can see the springs there and all the ejector pins. There's also a pair of screws that help us align and get the ejector pins to exactly the right level. Let me pull it apart even further. So you can see all this piece does is retain all our ejector pins. If I press this forward, a few of those ejector pins slide out. We'll leave 2 in for now. But you can see these slip in here. It's a nice fit. Nice smooth fit, and this piece just clamps them in place with that head. Let me take it apart even further. And these springs keep everything in place when the ejector pins aren't pushing plastic out of the mold. You can also see that our 2-piece design is really tight fit. In fact, pulling these things apart is a little bit of a pain, so I won't do it right now, but everything is nice and flush. It seals up well. We get very little flashing. But we're still running into 1 or 2 problems, and the guys at APSX have been really helpful in solving them. So let me talk a little bit about the problems we've run into so far. You can see our whole collection of mistakes here. Trust me, there were many more than this, but these are just the ones I happened to save. You can see there's a lot of partially injected parts. You've got some with just really excess flashing. And they all have individual reasons why that's happening. Part of it was injection mold temperature. You know, you got to get the plastic hot enough. It has to stay hot enough to be injected into the mold. Otherwise, you're going to solidify that plastic before it gets everywhere. That's what's going on with these. There's a few reasons that can happen. In our case, we thought that the temperature just was too low, so we turned up the temperature. And that to some degree. All right, future Mike here. Sorry to interrupt past Mike, but after a few more days of messing with this thing, I think we figured out the culprit of most of the problems. Good news is 2 of them are super easy to fix. Bad news is the third one, I'm still trying to figure out. All right, first problem we were having was with this big stepper motor. This motor drives 1/2 of the mold back and forth, and we noticed that after using the machine for about an hour, it would stop moving. It would start to pull back and it would whine like the motor was trying to move, but nothing was happening. And that's because this stepper motor was getting really, really hot. You see, as stepper motors get hot, they get less efficient, which means they're not able to put down as much torque. One of the reasons this motor is getting so hot is because they're driving it at full current no matter what, whether the motor is moving or not. You see, most stepper motors will reduce the current when the motor's not moving to prevent just this sort of thing. For some reason, they're driving this at full current no matter what. Now, there's a few easy fixes here. They could fix this in the firmware, and I'm going to be reaching out to APSX to see if they can do that. But in the meantime, I'm going to slap a few heat sinks and probably a fan on this thing. That should help a lot. The second problem we're having is very much related. It's this stepper motor that opens and closes the valve to let the plastic into the mold. It was also getting very hot, and for the same reason, full holding torque no matter what. This one is especially silly because it doesn't have to have any power going to the motor at all when it's not opening and closing the valve. The valve's not going to spring open or anything like that, so they could just turn off this motor 90% of the time. But instead, it runs at full current all the time. Again, super easy firmware fix, and hopefully APSX will do this pretty soon. For all I know, they may have already because we've got a new firmware update coming to this that we haven't tried out yet. So I'll update you when that comes in, but in the meantime, same solution. I'm going to put a heatsink and a fan on this so that we can get it running. The third problem is a little more tricky. You see, this stepper motor drives an auger that forces the plastic into the heated cylinder that melts the plastic. And for some reason, it keeps either getting jammed up or just isn't forcing the plastic in, which results in a mostly empty cylinder. So when the valve opens and forces plastic into the mold, there's no plastic for it to force, or even just a little bit of plastic. So let's look at this auger and see if we can figure out what's going on. All right, here's the auger, and my current theory of what's going wrong is the space between each of these threads. You see, it just happens that our pellet size is about just a little over 2 times that distance, which means every once in a while you'll get 2 pellets that get jammed between these 2 against each other, and then nothing can flow past it. Not 100% sure that's what's going on, but every time we've pulled it out, we've seen some pellets wedged in here. They're not wedged very hard, so I'm kind of surprised they don't work themselves out, but that seems to be what's going on. If you guys have any better theories, please let me know in the description. In the meantime, we've just been hand feeding the plastic into the tube and forcing it down with a screwdriver. Not the best solution, but it has worked. But hopefully we can get this sorted out in a more permanent fashion a little later. Okay, I know that was a lot to cover, and this video is probably obnoxiously long by now. But really, there's still a ton more. We've learned a lot. We're going to learn a lot more in the next few weeks. So if you guys are interested in this sort of video, please let us know in the comments. We obviously spend a lot of time and effort making these videos. So if this is something you're interested in, let us know. If it's not, let us know that too. And if you happen to know a lot about injection molding and you see we're doing something obviously wrong, please let us know in the comments about that too, because we are trying to learn a lot in a short amount of time. But I think that's going to do it for this episode. We'll see you guys on the next one. Where's that button? Oh, there it is. Yep, it's working. All right, see you guys.
I was hoping maybe we could have a little dialogue about that.
Man, basement's really coming along down there.
Good.
Yeah. Should we read some comments?
Sounds like a good idea to me.
Cool.
All right, so first of all, VP CNC says, clearly the new shop is a result of using Linux CNC.
Oh, they caught us.
Nathan says, do a video on the injection molder.
Done.
Max Maker says, I recommend watching all of Paul Akers' videos, a ton of great practical lean tips. You know, that's the thing where you're trying to make everything a little bit more accessible and better organization in your shop.
First order retrievability and all that stuff.
Yeah, pretty much if we can end up with like working space on tables, I'm pretty happy. But,
We've low standards.
You know,
but we'll definitely check that out. This is more shop space than we're used to having, so that's probably a good idea.
I'm sure we'll junk it up immediately. Paul says he's looking forward to hearing more about the injection molding machine.
Too bad.
Peter says, I'm convinced if you swap the hair and beard, you would look like the exact same other person.
Maybe if we swap faces and bodies too.
OpenD says, more work, more bills, new product development, More cash for more equipment. That's that's all we really want is more toys. If I had money, it would just buy more toys.
I think that's our business model, right?
Yeah. What's the profit? Please make a video about making PCBs with a laser. You got it, bud. I will do that.
Heck yeah.
Joe Gravel says, Publix, and the rest of the world learn where the best subs are born.
Darn right.
Yes. Burning Diesel Production asks, is there any way to purchase the knife without going through Kickstarter?
Oh, excellent question. We are going to be selling these probably on Amazon and on our own store at some point. It's going to take us a little while to catch up to all the Kickstarter orders, so look for it in, I don't know, 2 months?
Yeah, something like that. Kickstarter guys first, one way or another. Ed says, where's the death metal unicorn on the wall?
Oh, we've talked about that.
Bianca, what are you doing?
Yeah. How do you feel about like a 14-foot mural?
Kevin asks, is the injection molding machine a custom unit or off the shelf? If so, branded model. I think we covered that.
Links in the description.
Nice essential phone. I still got it.
Can't believe somebody recognized that.
I know. Anthony asks, will there be any updates for the Mach 3 skin?
Oh, absolutely. I've got a whole list of changes coming in the next version. I just need to find the time.
Thanks for shooting in 21.9.
Yes. It's only going to get wider from here, guys. At some point, you'll have 1 pixel all the way across, but it'll go on forever.
This channel is thick. 2 C's. Why are the subtitles in Korean? You probably have your subtitles set to Korean because we don't do subtitles.
We don't.
We should, but we don't.
Yeah. It's awesome that, I don't know if that's an auto Google Translate or if somebody is out there is writing subtitles
That's
for
a
us
good
in
question.
Korean.
If you're the person writing Korean subtitles for our channel, that's awesome.
Yeah, thanks.
We'd love to get to know you.
Yeah.
Plenty of room for the lathe rebuild. Sadly, the lathe won't come over here, but there is more room in our garage now because a couple of the big machines moved this way.
Yep.
So I'm not saying there's lathe content coming, but that aspect ratio, though. Everybody about...
I am shocked anyone
Yeah.
noticed the aspect ratio. I
Like,
mean,
you're going to have to show them why you ended up making super wide videos because it's just silly.
I'll tell you what, we will
Just jump to it right now.
Okay, fine. As my
He
monitors
thinks-
get wider, my videos get
He
wider.
thinks it's funny. His ladies, too. Wait, no. What system did you guys use for your shop air? It looks something like PEX. Hang on a moment.
How you guys doing? Having a good day? Not too bad? Cool.
It looks like PEX, but it's actually got this aluminum core in it, and it's lined with some kind of Teflon-y type thing. Really stiff stuff, but there's like a special tool to unroll it. I don't think it's ever going to break. I like it.
Yeah, the fittings are pretty high quality. It's not too expensive, actually. When you compare it to the regular hardline stuff, it's like probably a fifth the price.
Yeah. Thing in the...
Yeah.
Yeah. Someone who filmed in 21.9 and actually uploaded in 21.9.
Yeah.
What phones are you guys watching our videos on? I don't understand.
The funny thing is, most phones these days are wider than 16:9 aspect ratios.
Are you
All of the
kidding me?
Samsung ones are like 20:9. Yeah.
So you're going to upload in 20:9?
No.
You're planning the future where it's all going
That's
to be
right.
40
I know
by
it.
9.
I know where it's going.
Why is it by 9 anyway?
That's a good question. I don't know.
And when it's 18 by 9, isn't that
One by two.
1 by 2?
Yeah.
2 by
Or
1?
2 by 1. Yeah.
Well, 2 by 4 wasn't a ratio, nor was it a measurement, it turns out. I don't understand anything about anything today.
Well, if you're trying to make sense of the imperial measurement system, then you're at a loss. Especially when it comes to things like wood and pipe fittings and...
Fahrenheit makes perfect sense. I just want to point that out. It's not tied to a physical principle or whatever, I get that.
I'll cut back when he's done. Don't worry.
But for like human measurements, that's what we all understand. Whereas like the difference between 18 and 22C, like nobody cares.